Okay, just 1 minute. Hold
No
on, just
problem.
1 minute.
No problem.
Okay, 7 point. This one is, what is the maximum number of electrons in an atom that can have the following quantum numbers? Okay, let's start with this. N is equal to 2.
Mm-hmm. M sub
Ms
is
is equal to how much?
plus 1/2.
Plus 1/2, like a spin quantum number.
Yep.
And N is equal, oh, only this one, 2. Okay, what is the maximum number of electrons in an atom that can have the following quantum numbers? N is equal to 2 and Ms is equal to half,
1/2.
1/2. Okay, so
So it looks like.
how many electrons do you think?
Let me see. So if it's so two, so the first, like if n is equal to 2, then that means, would it be 6 plus 4? Is it 10?
Uh, 10. Okay. First of all, tell me what is the meaning of N is equal to 2? Second shell, am I right?
Right.
And second shell has either 2s or maybe 2p. Because
2s
N
or
is equal
2p,
to 2.
right?
And second shell do not have 2d.
No
This
2p.
is not there.
Yep.
Second shell has only 2s and 2p. Because we already know that how many orbitals are going to be there is going to be 2n, like in this case, 2s and 2p. So 1 orbital here and 3 orbital here in the p. We do not have d orbital in second shell.
Okay.
So now can you tell me how many electron can have this on the maximum number of electrons?
Well, would it only be like 2, 4, 6, maybe, or let me see. It's, if the spin is 1/2, so it'd be 1, 2, 3, right?
Because we have 4 orbitals, am I right?
So would it be
How
4?
many orbitals are in the second
So
shell?
would it be just 4?
4. So that's 4, because if one electron is clockwise, the other one is going to be counterclockwise. Clockwise, counterclockwise, clockwise, counterclockwise. So if this one is plus half, so this one is going to be plus half. The other 4 are going to have minus half. So we only can, the maximum electron is going to be 4. Because the other 4 of them are going to be plus half, other 4 are going to be have minus half. It's clear?
Okay. Yeah.
So the maximum number of electron which can have same spin in a particular shell depends on the number of orbitals in that shell. So in the second shell we have only 2 subshell and 4 orbitals. 4 orbitals means 4 can have this thing. Is clear?
Got it.
Now let's try the next one.
Yeah, I'll try part B. So it's saying
B, they are asking again maximum number of electrons, but now the N is equal to 4. L is ML. Now they are not giving MS, they are giving ML. Is equal to what?
plus 1.
Plus 1. Plus 1.
Okay. So let's see.
What are the ML values for
It'd be
for the N is equal to 4? What are the L values for this
it'd
one?
be minus or 0 to 3, right?
0 to 3. 0, 1, 2 and 3. You're right. So this is S, P, D and F subshell. And the ML they are saying ML is equal to plus 1. So now tell me how many maximum electrons and also explain your answer.
So would that mean for each S, P, D, and F? Let's see. So S can't have a +1, right? Because it's only the only or ML is equal to +1.
No,
Like
no, S. What is the ML value for S?
0. So it can't be that.
0. So it can be that. Yes, that's right.
It cannot be, right?
Yes, cannot be.
Okay. So the only ones that would have +1 is P, yeah? Or this, it'd be -1, 0, and +1 for P, and also these would include it.
Yes.
Would
So
also include.
it means in one orbital, in +1 is going to be one orbital here, 1. Also +1 is going to be here, 1. And also +1 is going to be here, 1. So how many orbitals are there which have +1?
3.
Altogether, 3. And each orbital can accommodate how many electrons?
2.
So how many maximum electrons can have Ml +1?
6.
6. That's it. You can check your answer.
Yep, that's right.
Clear?
Yes,
Because
that's right.
S cannot have +1. Because if this is 0, Ml is going to be 0. There is no +1. This one has +1, this will also include +1, this one also include. So total orbitals are 3, 1 in each with +1.
Got it.
Each orbital can accommodate 2, so 2 times 3 is 6. Is clear?
Yes, yes. I'll give. I'll try C. I'll try part C.
Okay, try the C by yourself.
All right. So it's asking maximum number of electrons in. So n is equal.
What are
to,
the values given here?
N is equal to 3.
N is equal to 3.
And L is equal to 2.
L is equal to 2. Okay.
Yep.
Not only give the answer, also explain it to me.
Okay. All right. So since n is equal to 3, they're already giving me an L value. We know that M sub L could go from 0 to 2. So it'd be 0, 1, 2, which is S, P, and D orbitals. Okay. So let's see, if L is 2, though, that's only the D orbital, right?
You're right.
So the D orbital, there's 5 of them, right?
Yes, 5
So-
orbitals are there.
So 5 D orbitals would be, each has 2 electrons possible, so it would be a total of 10 electrons, right?
Excellent. Yes, very good.
Okay.
You can check your answer. You're right.
Yes, that's for part C. That was correct.
Okay, so that's good.
All right.
10 electrons. Okay.
I'll try
Now do the D part also by
Yep.
yourself.
D and E. I'll do E right after. So D is N is equal to 2.
Okay, ML is equal to 0 and MS is equal to.
Negative.
Okay, first of all, I will explain this, go back again
Mm-hmm.
here in C. Then you will do this one. Whenever you are doing this thing, this type of question, first of all, locate what orbital you are talking about. Because N is equal to 3, so I know it is 3. L is equal to 2 and 2 stands for the D orbital.
Mm-hmm.
Alright?
Right.
And now, because I know that how many orbitals are in the D?
5.
5.
Five to
Suppose
work
if I say, I also give you another one, spin quantum number.
Mm-hmm.
So then each of them is going to be clockwise and counterclockwise. Am I right?
Right. Right.
Now do this one, the D part.
Okay. So for D, we have N is 2. The possible L values would go from 0 to 1. But in this case here, they're wanting us to just work with the 0. Okay. So then the spin quantum number is -1/2. So they're asking, what is the maximum number of electrons in an atom that can have these? It would only be 1 electron, and because
Very good, excellent.
right, the s
Why? Why?
the s orbital, there's only one.
Can you write that on the whole orbital together, like here, which and where is the electron? And
Yes.
show me the electron in the orbital.
Yep. Yep. So if it were, this is the,
What
this
orbital?
if this were the 2s one, right?
2s1. Very good.
Yep. So
2s can has 2, but with only minus half is going to be only 1.
and it's just
So only one,
that one.
yes.
That's
So
negative.
only one electron can have. The other one is going to be have plus 1,
Yep.
plus half.
Yes,
Okay.
sir.
Excellent. Okay, now let's try this one. N is equal to 4. 4. L is equal to 3.
Yep. And
ML is equal to minus 2. Now you do it, not only give the answer, but also show where the electron is.
okay. All right. So let's see. Yeah, this is given, and we're gonna target the -2. Let's see. So just let me think for a moment here. We got the third energy level. So if it's -2, is this like let me see, like
First locate, just like you located here, this one. You told me 2s electron is like, first tell me where is the,
okay, so
give the correct address of this apartment, you can say.
oh, okay. So this is D, right? Hold on, S.
No,
D.
this is not going to be D. 0, 1, 2, 3 starts with 0. 0 is, S. In the previous example, L is equal to 0, it correctly says S.
Right. Yeah, this
So
is
this one is F.
This is going to be the 4F.
4F, very good. And now can you make all the orbital and like the building and then locate a particular apartment?
Right. So there's
Start writing the apartment number from beginning to the end. Of course, we don't need, but just I'm asking to make that one. So how many apartment has -2 number?
possible would be
Only
2.
one. So one orbital is only which has -2. So how many maximum electrons should be there?
2.
2. That's correct. And you can check your answer.
Just that one, yeah?
Yep. So that's also you're locating in which apartment, which orbital the electron is.
Yep, yeah, it says 2. Yep.
Okay?
Yeah, that was a good question. It worked through each layer, you know what I mean, of the quantum
So-
numbers.
Whenever you're doing, you have to understand like making all these things, making like, so I say it's apartment number.
Mm-hmm, mm-hmm.
And each apartment, 2 people are living.
Yes, I like that one. That's good.
Okay? So now we did this one.
Yep.
And I
we're all
uploaded
done.
something related to your whatever you are doing, okay?
Yep.
This is the formula sheet. Okay, let me do this question. No, sorry, this one. You did the hydrogen spectrum or other things?
I believe so.
Okay.
Let me see.
So because in hydrogen spectrum,
He did mention.
I don't know whether you have done this thing or not. If you have done the hydrogen spectrum,
Yeah, he's. I think he like briefly mentioned it, but I can.
okay,
give it a
this is
shot.
not hydrogen spectrum. This is very easy without even spectrum looking because they're not asking the spectral line names. So just look and tell me.
All right.
Of the following transition in the Bohr hydrogen atom, the dash transition results in the emission of the lowest energy photon.
Okay. Lowest energy. Okay. Let me see.
Emission of
Mhm.
the lowest energy photon.
Would it be C?
Mm.
No.
Okay, first of all, important thing is they are saying not absorption. They are saying what? Emission. And emission is only possible when electron is coming from higher orbit to lower orbit.
Okay. Higher to lower.
Higher
Okay.
to lower.
So in that case, would it be E?
Is going to be that looks good to me
E?
because 6 the difference is more. So
Mhm.
that's correct. E is the correct answer in this case. Okay,
Yeah.
is it
If
clear?
and if it
I'll
if
try the another one.
if yeah, but if you said like if we use the same question and we just say of the emission of the
Absorption,
highest,
absorption. Result in the absorption. Then what will be the answer in that case?
the absorption of the lowest energy photon.
Oh, sorry. I'm wrong. Sorry, I'm wrong. Because it is not the highest energy. It is saying lowest energy. Sorry,
Mm-hmm.
they are not saying highest. They are using the lowest energy. Sorry, like less energy, least
Yeah.
energy.
Right.
So which one is there? Of course, again it is the from higher to lower. That's right.
Mm-hmm.
But which will give you the lowest energy? Where the difference
Would it
lowest energy there? Which question we are doing?
3?
Okay. So now look here in this case. 6 and 3. Lowest energy photon. 6 to 3. Here it is. Oh, your answer is correct. Your answer is correct. Because the other one is 6 to 1 is a big difference.
Yeah. So that would be like
Difference.
the largest.
Only I see this one. Okay, that's correct. That's correct. Suppose if the same question is absorption, then what would be the correct answer?
Would it be C? I'm not sure. No.
You're right,
Is
3
it?
to 6, because now it is opposite of that one. It's clear? Because
So
going from 1 to 6 will take too much energy. 1 to 4 is also 4 difference. Here it is less difference. So that's going to be the correct answer in case if it is absorption.
So talking absorption is going from lower to higher, and then
Yes,
emission is
like
higher to lower.
absorption is you are when you if you are living in a building in the and top floor, a
Mhm.
third, fourth floor.
Mm-hmm.
When you go up, your energy, you are using energy and you become tired. Am I right?
Yes.
So you are absorbing energy. It's like
Okay.
when you come down, you don't have to spend energy too much. Your potential energy is decreasing. That's why you don't feel tired in coming
Okay.
down. It's clear?
Got it.
Okay, this one.
So in the Bohr model of an atom, let's see.
You can also use like if we don't have the answer, just click the wrong answer and then you will eliminate the wrong answer.
I'm thinking A is correct.
That's correct, 100% correct.
That's the
Because
only one here that works.
because it's quantized. Because it's why it is quantized, because they can emit photon 1, 2, 3 like that. If the energy of one photon is 3, so if two photon, you will not get 3.5 or 4 energy. Another 3. So 3 will give you 3 times 2 6. Third photon it will give 9. Multiple values of that.
Okay, multiples.
So that's we call quantized in scientific
Mm-hmm.
terminology.
Got it.
Okay, now let's okay, this one you already know
Which one?
which one is correct. This 6, question number 6. Which one of the following is
it
correct?
D? Let me see. Hold on. C is equal to lambda nu. Okay, C.
C is equal to. You're right. So whenever
Right.
you have this thing, instead of paying attention in time, you can write what is the relationship between nu and lambda, and we know nu and lambda is this. So they cross multiplication, and you will get nu lambda is equal to C, right?
Mm-hmm. Yep.
Your answer is correct.
Good to go. Yep.
What about the 7?
Which one of the following is not a valid value for the magnetic quantum number of an electron in a 5D?
Yeah, magnetic quantum like ML value. ML value.
Okay. 5D. Okay. Let's see. Hold on. So ML could be 1, -1, 3, 0. SPD means 4, 0 to 4. Could they all be?
No, because you have to choose from here. Okay, just tell me, what is the L value for D?
A 5D subshell.
No, just tell me about D, because it doesn't matter 4D, 3, 5D. What is the L value for D? D subshell. You know L starts with 0?
Yeah, 0 to
0, 1, 2, something like that.
D is 1.
D is 2 because S is 0.
Or, I'm sorry.
And the L value you know.
D is 2. Okay.
D is 2. So 2. So what is the ML value for D?
-2, -1, 0.
And up to +2.
Okay.
All number, including zeros. Am I right?
Right. So
So
it'd be
that's
C.
C is the correct because C is not possible there.
Got it. Okay.
What about the 8th question?
Okay. Which of the subshells below do not exist due to the constraints upon the angular momentum quantum number, which do not exist?
Angular momentum like L value.
L value. Okay. So 2p, that does exist. 2d. Yeah, it does not exist because the 2s does exist.
What about?
Yeah, 2d
what about,
does not.
Which is the correct answer?
B.
B, you're right. Why? It is not because you know that 2D we don't have 2D.
We can only have 3D.
D starts with because second shell has how many orbitals? The number of orbitals subshell.
P.
In second you have 0, 1 and 2. 0 and 1. The L value is always 0, 2 and -1. And for p orbital 0 and because it's 2, 2 minus 1 is 1, so 0 and 1 possible. For d orbital it's a 2d. I am taking 0 and 1. I don't see like 0 is s, 1 is p. I don't see d orbital because for d we need 2 and I don't have 2 here.
Got it.
In the 2d. Am I right?
Right. You're right.
Okay, what about
9? Wait, let me
9?
see. I'll try ML.
Okay.
Which of the subshells below do not exist? Okay. 4F, I believe it. Yeah, that's there. 4P is possible. 4S is possible. 4D is possible. So it'd be. Would E be the right one this time?
You're right.
None of the above.
Right. Yes.
Right? Because they're all
Yeah,
possibilities.
very good. Excellent. Now do the 10.
10. An electron cannot have the quantum numbers N, L, M sub L. Let's see. So going through A first. N is 2. L is 1. That is possible. So A looks like it does work. B, let's see. 2, 0, Yeah, it is possible for that one, right? Let me see.
Mm.
Okay, D. D is the answer because N and L cannot be the same.
Yes, you're right. 100% right.
N and L. All right.
That's correct. A
11.
similar question is here.
Yep, an electron cannot have the numbers 3, 2, 1. That looks good. 3, 2, 3. It does not work because M sub L can't have
Is
a
not
can't
can
have a
have
number
3
of that
because it's going to be
greater, right?
from -2 to +2.
Mm-hmm, mm-hmm.
That's correct.
All these others look good. All right.
Mm.
So 12. Which one of the following is an incorrect subshell notation? This one, E, 2D.
Correct. Yes, because we do not have D in the second shell.
All right. 13. Which quantum number determines the energy of an electron in a hydrogen atom?
Mm.
So it'd be C?
Not only
No.
this, but also this one,
And,
E.
and L.
You know, in the beginning, I told you like one of the question, like whenever you have to decide which energy is more energy or
Right.
less
You're right.
energy,
Yep.
so look the N plus L value.
And if they have the
So
same
between
L
these
value.
two quantum number we have to.
Okay.
Okay.
You're right. You're right. Yep. All right. And
But oh, sorry, in hydrogen atom, because they're asking hydrogen atom, so forget about hydrogen. In hydrogen atom, C is correct because hydrogen has just the electron is in the s or 1s orbital,
mm-hmm.
and thus we only look like in
Okay.
that case it is going. But generally it is N plus L. So in this case, N is okay
Got it.
because you know the different series going from the second shell to third shell, the Balmer series, Pascal series,
Mm-hmm.
only depends on N value. So in this case, C is correct. You're right.
Okay.
What about the 14 one?
All right. In a px orbital, the subscript x denotes the. Isn't that the orientation? Let me see. The size of the orbital? No. Energy of the electron spin probability of the shell. Axis. Yeah, E. Axis along which
E
the
is
orbital
correct.
is
You're
aligned.
right. You're right.
I like-
Axis and orientation, same thing.
Yep.
Yes. What about 15?
All right. The blank orbital is degenerate with the 5py in a many electron atom. Let me see. Is degenerate. Let me see. 5p.
What is the meaning of degenerate? Degenerate.
I should know this. Let's see. I gotta look this up.
Orbitals having the same energy.
Would this answer be 5px?
You're right, because 5px, 5py, 5pz, they all have same energy.
Right.
Okay.
And
Any orbital which has same n and like same energy, they are going to be degenerate.
If, like, a 5px would be filled before a 5py, is that true? Like xy?
No.
Z?
They are
No.
degenerate means you can put anyone
Anywhere.
first.
Okay.
Of course, we generally write px, py, pz, but even if someone write like this, suppose I have to put 3 electron
Mm-hmm.
in px, 3px, and somebody put here electron. This is, sorry, px, py, and pz. So he's not wrong. He's still correct.
Okay.
Other putting here, it's still correct. One other one putting in the middle. Of course, we write from the order from left to right, but they are not wrong
Okay. Okay.
because they are all of the same energy.
Got it.
That's why we call degenerate, same in energy. You can place electron anywhere.
Got it. Understood. Which
So
one?
in case if somebody give you like this and says right or wrong, so it's right.
It is right. Okay.
Yeah, it's not wrong. What about this one?
Which one of the following orbitals can hold 2 electrons?
Hmm.
Okay, let me see. 2px. That could, let's see, 4dxy.
Hmm.
I'm not, like, 2px. If this was 2px, right? This one orbital
Yes.
could hold two
Mm-hmm.
electrons.
Okay.
If it were just
Yes.
a 3s orbital, it could hold two electrons as well.
Yes.
So A would work,
Yes.
3 would work. Now 4dxy, I'm not sure.
Also is one orbital.
This xy is 1.
Yeah, dxy,
Okay.
this is direction. So xy it is like between the x and y axis, the d orbital lobes. So still it is one orbital,
Mm-hmm.
but the direction is between x and y axis. That's why they are saying dxy. The lobes are like this, between x and y axis.
Oh wow.
So still the orbital is only one.
Okay. So and it would be all of them because they all could
You are
hold
right.
two
All of the
electrons.
above. Yes.
Okay.
What about 17?
Which quantum numbers must be the same for the orbitals that they designate to be degenerate in a many electron system?
What quantum number must be the same for the orbitals that they designate to be degenerate? And degenerate you already know.
Mm-hmm. Let me see. So ns, the spin, those quantum
No,
numbers.
spin
hold on.
doesn't matter about the
Mhm.
for the degenerate. I told you like when I was giving the answer and I changed to the C before the C choice for N only.
So n and
I
l.
told
N and l.
N and
only.
L. Yes.
Only.
So in this case D.
D.
That's I changed because it was only for the hydrogen spectra like that one.
Yeah, because it's like when you were making those lists and we were going through
Mm.
each one, the N and L were the same for all of them in the group,
Yeah.
and then the only thing that would change was that M sub L or the S, the spin number.
Like is
Okay.
in that case the N and L, if both of them are same, then it's going to be same energy.
Okay.
Both of them we need. Okay, what about the 18?
Which of the following is not a valid set of 4 quantum numbers? Okay. Right off the bat, I spotted A because it's 1 and 1.
You're
for
right,
N and L.
because they cannot be same. Okay, that's correct.
Yep.
Okay, what about 19?
19. Yeah, A right off the bat because it's because the M
19?
the sub for 19A.
Yes, but why it is not good?
The M sub L is greater.
You're right, because
than
if
the
L is 1,
Mhm.
ML cannot be like more than, is going to be between 1 and minus 1.
Yep.
So that's why, that's correct.
Yep.
Okay, now let's do the 20.
All right.
Now, if you want, I can review the things, the 4 laws. Aufbau principle tells you that electrons are, you have to arrange in order of increasing energy, from lower energy to higher energy.
Mhm.
Okay? First, you will search the room which has low cost, then you will go to the higher cost. Okay? If it is not available, that's Aufbau principle. Pauli-Stojan Hund's rule says if degenerate orbitals, equal energy orbitals are available, they are going to prefer to occupy them singly. You know that I gave you the example. If each people, not with the partner alone, they are going to see a site on a bus or train, suppose in Switzerland, and no one is with his friend.
They all
So
want
in
a
that
window
case,
seat.
everyone wants to join the window seat. Am I
Yep.
right?
Right.
So that's like you can say when window seat is available, they are going to occupy separately, and they are not going to sit here away from the window. No, they are going to sit with the window.
Yeah.
So that is like with the same spin. And the Pauli-Exclusion principle says definitely if all single seats are occupied, the other person, if I want to sit, they have to sit away from the window, like counterclockwise, opposite spin. Am I right? So now look these questions.
So Pauli is the opposite of
Opposite spin.
Okay.
If they have in the same orbital. Now read this one. Which
which
electron
configuration?
configuration is a violation of Pauli? So you have to just tell maybe other violation is there, but this question is asking about the Pauli exclusion principle.
Mhm.
It is just like giving a
Yeah.
ticket. Either you are the parking ticket or you are breaking the signal, so you have to write the correct code.
A is right because it should be It should be the one
No,
going down and down.
no, but
No.
I don't see any same. Pauli student principle violation is having the same spin in the same room, same orbital. I
Oh,
don't see like this. Okay, this is not correct. I'm not saying this is right,
so
but I can give the ticket for this one.
E would be the right one for this one.
E is the right one. So
Okay.
you have to give the proper ticket. This is a violation of this rule. Okay. Okay. What about the next one?
Okay. Violation of the Pauli exclusion. Okay. So like we said, it'd be A because they're going up. They're both in the same direction. They have to be,
You're right.
right? Okay.
What about this?
Hund's rule. Okay. Violation. Hund's rule, we said, if equal availability, then they all get a window seat. Let me see.
Which one?
Or would this be?
This is violation, but not a Hund's rule violation.
This one. D.
D is right because these three p orbitals are degenerate, same energy. But instead of taking a window seat, they are sitting on the same window in opposite, like in the same,
Yep.
with the same, not occupying separately with the same spin.
Right.
What about, is this is correct or wrong? Of course, they are not asking the question I'm asking.
I remember you telling me that this would be correct. This would be
This is correct. Many people think that this is wrong, electron should be here, but it doesn't matter. All of them are same energy.
Mhm.
Okay. What about 23?
So violation of Hund's, let's see. It'd be this one, D, right?
Hmm?
No, hold on. Hund's rule. Yeah, it'd be the.
You're right, you're right. Okay, what about this one?
Alright, oxygen. Let's see. So we know oxygen is 8 electrons. So we know helium has 2.
What is the atomic number of oxygen? First of all, tell me.
8.
8. So you have 8 electron. Okay.
Mhm.
Now, what is the regular configuration of oxygen? Can you write here? Or just tell me?
Yeah, oxygen, let's see. So it should be 1s2.
I'm writing 1s2,
Yep. 2s2.
2s2,
2p4.
2p4. Okay. 2p4. That's good. And p4 is like this, am I right? 1, 2, 3, 4. Now, do we have 2d orbital or not?
No.
We don't have 2d orbital. That's not. Now read this one. Which of the one of the following configuration depicts an excited oxygen atom? So look here in this
So wait,
case.
which one would it be? We have 1s2, 2s2, 2p4. So it could be this one. What about
No, this is the correct, but they are saying not, this is the ground state. They are saying excited state.
oh wow, okay. I'm sorry. So
Like going to some other higher shell.
yep. So an excited oxygen would be one more, right?
Maybe d orbital is not there, so you can go to third shell, something like that. Look, this one is only 6 electrons, so not possible.
Yeah.
This one is 2 electron to 4 and 4 8. This is good, but only for the ground state. This
Right.
one.
That's like the same as D.
Same as D, just no difference.
Mhm.
This one is again 5 electrons, so this is also eliminating this one.
Mhm.
So even after elimination and everything, I know this one. And look why. If you count the electron, it is still 8. Am I right?
Right.
But now the electron, instead of 2p4, two electron from the 2p, like out of
okay.
4 electron, are jumping and going to the next higher shell, third shell, and going to the higher energy shell, either 2D is not here in this case, so 3s, the going from here to here is going to excited state.
Got
Right?
it. Got it. Understood. So it'd be E.
This is not a regular ground, but excited state.
Got it.
What about this? Ground state means like a normal configuration.
Okay. So
What is the
25.
atomic number of fluorine?
We have 9.
9. So just tell me the correct answer.
All right. Let's see. So helium, they got 2, 4, 6. Can't be A. Helium is 2 and 4, and 6 would be 10, so it can't be that. Helium is 2 and 2 is 4, and 3 is 7, so it can't be that one. Helium is 2 plus 2 is 4, and 8. It can't be that one. So helium is 2.
This 2 is like a mistake, double 2.
No worries. 2 and 2 is 4, and 5 we have 9. So I
That's correct.
think
Okay.
yeah, that one should be
So
good.
now let's go to another one. Whenever you want to stop, you can just let me know, okay?
Yeah, no worries. Yep. You
We'll
do have
take
another
this
one, like another worksheet.
This one, yes.
Okay.
This one is a little calculations. Maybe also
No
other
problem.
things are there.
Yeah, it's good. It's good that these are some more like energy and frequency or wavelength type thing. Okay. Yeah, it's good for me to I'll practice these. Let's see. So light passing through a transparent medium has a wavelength. Okay, lambda is equal to 466 nanometers. Okay, and frequency 6.20. All right. What is the speed of the light? Okay, let's see. So speed. I'm just trying to think here. V. So V is for speed, right?
What is the speed of the light in the medium?
Yeah, I have to look
Normally,
at
the speed of light is constant, but there's in a particular medium they are saying.
right.
In the vacuum, it is 3 into 10 to the power 8, but here that's something else, not the same.
Okay. Yeah, can I look at the formula sheet that you gave me? I
Yeah,
have
but
it
you have to
printed.
modify. Yes, you can look
I
here.
just have to look and see at the
Let
find
me.
the
I will
formula
go back
that
and
includes
see.
V.
It's also here. Also, I put there.
Okay, so
Look, this is the formula. Can you see? Like mu is equal to c over lambda.
yeah, which one is speed?
Okay, but in this c is the speed of light. But in the medium, you can just write the v, or you can write c dash. It's still the velocity of light, but in this c is in the vacuum or in the air, which we take 3 in times 10 to the power 8. But if suppose the light is passing through water or glass, the speed changes. That's like a medium.
Okay.
So you can say like it is c dash, or maybe v. You can say, you can just change the symbol and use the same equation of velocity.
Okay. So we can.
Or you can just put v if you want. This is nu, not the v.
Okay. So we can
You
say
can put v like v.
V equals.
Or you can put C dash.
Lambda nu. Lambda times nu.
Yeah, so c is equal to what formula we are going to use?
Lambda times nu.
Yes.
Right. Frequency times the wavelength.
Yes, you're right. But it is an c dash I'm just putting because it is not the same constant.
Okay. So for this one, I'm getting answer B. Answer B.
Answer B. Okay, let's check. B, hold on just a minute. 66.
Oh wait, no. I have to convert the nanometers to meters. So that's what I have to do first. Let's see. So 466 nanometers is equal to
What is your answer?
Would it be, let's see, if it's 2.8 times 10 to the, so that's 1, 2, 3, 4, 5, 6, 7, 8. Okay. So E.
That's correct.
E. Okay.
Now, this is a theoretical question.
Yep.
Question number 2.
All right. It's saying choose the incorrect statement concerning electromagnetic radiation. All right. The speed of ultraviolet light rays is faster than X-rays in a vacuum. Let's see. So UV light is faster than X-ray. So UV and X-ray.
But they are saying incorrect, remember.
Right. Yeah, I'm just trying to look at the electromagnetic spectrum in comparison to like wavelengths and energy and frequency, just to try to make sense to see if it is correct. So it looks like that one is correct, right? Yeah, they are faster. Okay. Infrared light.
Which one is correct? No.
Is A
what you are
correct?
saying?
Is A correct? Like,
Which one has more energy, X-rays or ultraviolet? Which one has more energy, I'm asking.
UV light.
UV or X-rays?
Yeah, UV has less energy than X-rays.
So that you already know that E is equal to H nu, am I right?
Yes.
E is equal to H nu. And also you know that E is equal to H nu. And you also know E is equal to mc square, am I right?
Right.
And C is not only the velocity of light but also velocity of radiation. So higher the velocity, more will be the energy. So if more energy is there, more speed
velocity.
is going to be there.
Okay. Okay. So they're comparing ultraviolet and X-rays. So since X-rays are more energy, they'd be faster. The speed of UV rays is faster
This
than
looks
X-rays.
wrong to me.
So this
right?
is it is incorrect. Yeah, you're right.
Okay. Why other one, just check. Other one are correct, but read that one. So it maybe help you in other problem depending they will give you. Why infrared light has a lower wavelength? Because infrared light has lower energy than ultraviolet. So more energy has higher, longer wavelength. Shorter wavelength. So ultraviolet, because you know that, as I told you, E is equal to H nu. So energy is directly proportional to frequency, but also inversely proportional to lambda. This means shorter wavelength, more energy. Longer wavelength, less energy. That's why it is correct, B.
Okay.
Because infrared has less energy, means longer wavelength.
Okay.
Electromagnetic radiation energy transmission, in which electric and magnetic fields are propagated as waves. That's right. The greater the frequency of the electromagnetic radiation, the greater energy, according to this equation, E is equal to H nu.
Because they're directly proportional. Okay.
Yes. A photon with a wavelength of 5000 angstrom has 1/2 as much energy as a photon with a wavelength of 25. Okay, because when you are changing this one, a photon with a wavelength of 5000, so wavelength is 5000. So frequency of is going to be less, its frequency is going to be double. So that's why as much energy as photon has a wavelength of 5000 angstrom has 1/2. So that's why it has 1/2 energy, because its wavelength is opposite to the energy.
Right. The longer,
Shorter wavelength means more energy, and they are double. So this is like 1/2. That's correct. Okay, now let's go to the next third question.
All right. It says the relationship between the frequency of light and the energy of light was postulated by. Let's see. I just have to read the names and then just maybe like 30 seconds to just try and think about it. Is it either Balmer or Rydberg?
No,
No.
because you know the equation you use for energy and frequency E is equal to h nu is what you give that name.
Is it Max Planck?
Planck's, yes, that's right. Planck's equation.
Because it's got Planck's constant. Okay.
Yeah, that's why. So
Max
Planck's equation, Planck's constant, that's the
Max
C.
Planck. All right. Good to go.
It's Planck. Okay, so just read that name
Yep.
of the equation.
All right.
Okay, what about the next one?
4. A radiation detector exposed sunlight records of the energy falling on a given area each unit time. If such a detector has a reading of 0.430 calories per centimeter per minute, how many photons of sunlight are striking each cm squared in 1 minute? Assume the average wavelength of sunlight is 460 nanometers.
And
Okay.
also conversion is given here.
Okay.
4.184 joules is equal to 1 calorie. Okay.
Okay.
So first of all, I want to make it joules, this one. Okay. Or otherwise you can do it later, no problem. We need to convert this one, photons.
Okay.
A radiation detector exposed sunlight records the energy falling on a given area each time. If such a detector has a reading 4.430, can you convert this into joules first?
Okay. Yep. So
How I can convert,
we have to multiply it by that conversion factor.
because this is calories, am I right?
Right.
So calories, and
So be 1.
I know that 1 calorie is equal to 4.184 joules. Calorie cancel, and I will get multiply by that.
Yep.
So what you're getting?
So after rounding 1.8, or if we want to keep 3 sig figs, it would be 1.80.
Okay, 1.80. Okay, so that's the joules we
That's
have.
the joules.
All other things we are keeping like that.
Okay.
So point this one per minute. How many photons of sunlight are striking? First of all, you have to look what is the energy of each photon. Energy of each photon also. Each photon. How you are going to calculate this thing?
I'm just trying to think real quick. Would it be E is equal to H nu?
That's right. And what about with the
Right.
wavelength? What's the formula with the wavelength?
So E is equal to HC over nu.
Lambda. Right?
Yes.
Okay,
lambda.
so we can use,
Oh,
but
HC
be
over
careful.
lambda.
What is the value of H?
We have 3
6.63
Yeah.
times 10 to the power, I think, minus 34 joules second. And this one is C is 3 times 10 to the power 8. And lambda is 460. Do I have to change something or not? This is nanometer.
Yep. I'll have to convert it.
Just put 10 to the power minus 9. It will be there.
All right. So I'm getting 4.32 times 10 to the minus 19.
Okay.
Right?
How much you are getting? 4.32, am I right?
Yeah. Times 10 to the. Let me see.
Minus 19. That's okay, correct. That's right. Okay. Now take this one, the whole thing, but instead of calories, take the joules, which we already have converted. This one. So I'm going to do like this one.
So we have to convert
You
it
are-
to calories.
Yeah, joules.
Oh.
Yeah, because
Wait.
this we are getting this joules from here. Alright?
Right. So what are we doing with this one?
I'm going to use this value, this thing, but instead of 0.430, I'm using 1.80 joules, which we already have converted.
Uh-huh.
And all other things are same, joules per centimeter square per minute, everything like that. And now I'm dividing by this one, 4.32 times 10 to the power minus, because this includes many photons. This is energy of many photons, many photons, and this is one photon. So that will give you the number. How much you are getting?
Pretty large number.
What is that?
4,166,666.67.
And what about 10 to the power what?
That'd be 4.16 times 10 to the...
You don't have in the exponential form? Answer.
Times 10 to the 6. No, my calculator is not showing it in that.
Oh, I got
have
it.
to-
My answer is like this one. I have my calculator is showing 4.166 and so on 66 times 10 to the power minus, sorry, not minus. This because it's not going to be possible minus 18. Sorry, because a number of photons like this. So what is the correct answer now?
1.36 times 10 to the 17.
No, not 17. It's power 18. Yeah, 4.17. You're right. But 10 to the power 18. This one is the correct answer.
Well, I didn't do it correct. So I wrote down 1.80 divided by this.
Yes, because this is, for example, like suppose you are bringing like $1,000, and each of their bill is $100. So how many bills you have? You have $1,000. Each of them, each bill is $100. So 100 divided by, sorry, 1,000 divided by 100. So it means you have 10 $100 bills. Am I right?
Right.
So this is a total amount 1.80 joules. And each bill or each photon has energy of this. So I'm looking how many photons are there. Let me I will show you again.
The answer I'm
You have
getting is
dollar
actually...
thousand, and each of them have the same bill. And now I'm dividing by $100 bill.
Yeah, it equals 10.
So I will get 10 bill, 10 of $100 bill. Am I right?
Right.
That's the same thing we are doing here.
But listen to what I'm trying to say, though. On the calculator, you have 1.80, and then you hit the division sign, okay? And then you divide it by 432 times 10 to the negative 19 power. The answer on the
I
calculator
divided by
shows...
4.32.
Oh, so that's the mistake that I was making. I wasn't dividing by 4.32. I was dividing by 432 times 10 to the minus 19.
I divided this.
Okay, so that's what the problem was. So I'll redo it again. Because this to me says 432
Oh, because
times 10 to the minus 19.
yes, maybe you're not visible. Like of course I have written there.
Now at this point,
Make it more visible.
now I'm
like
getting
this.
C.
See, that's correct. And also look, when they are asking the number of photons, it's not going to be with a negative power. Suppose I am making a mistake in using calculator, and my answer is giving me like 10 to the power minus 14. So it's not going to be possible. I know number of photons are going to be positive power. Number more than one photon, not less than, photon cannot be 0.1, am I right? 0.01, like that.
Right.
So double check if your calculator is giving number of photons with a negative power. It's not possible. Okay, what about the next?
Okay. So, let's see. Radiation detector. Exposed sunlight. If detector is reading, so 0.698 calories per cm, -2 minute.
It is same type of question you do it. This
Yeah.
thing.
How many photons of light are striking there in 1 minute? Assume the average wavelength of the sunlight is, okay, is 460 nanometers. Okay. So I need to convert nanometers to meters, right? 460 times 10 to the minus 9 meters.
Very good.
Okay.
What other conversion you have to do?
0.698 calories to joules.
Yes.
1 calorie is equal to, we got 4.184 joules. Okay. So I'm just going to put it in the calculator real quick. 0.698 times 4.184. We're getting 2.920 meters. I'm sorry, joules. Okay.
Okay, yes, correct.
Alright. So, let me see.
How much joules you are getting?
2.920 times 10 to the 0 power.
Okay. 10 to the power 0?
Yeah. Yeah,
Okay.
I put my calculator in scientific
because-
notation.
Okay, that's correct. Okay.
Okay.
And what about, what other thing you have to do now?
I just gotta read it real quick. Alright, so I gotta calculate E, the energy of the photons. Let's see. So 6.63 times 10 to the -34 power times C, which is 3 times 10 to the 8 power, over the wavelength, which is 460 times 10 to the -9, will give me the energy value. So that's alright, I'm getting 4.3239 times 10 to the -19 joules. Okay.
How much?
4.3239 times 10 to the -19 power joules.
Your answer?
No, I haven't given the final answer yet. I'm doing it
Okay,
step by
okay.
step. I just calculated energy from
Okay,
E
okay,
equals
okay.
hc over lambda. So that was my answer when I got hc over lambda. So that's my E value. So
Okay.
now I'm just trying to determine what to do next to divide it by 2.920, and then I'm getting 1.48 times 10 to the -19 power, which is incorrect. So I just have to figure out what I'm doing wrong here. Oh no, I have to divide 2.920 divided by 4.3239 times 10 to the -19. Oh, fuck. Yeah, it should be B. Bravo. Right? Would the answer be B? Bravo? 6 points.
You are right. Correct. Very good.
Because at first I was dividing.
And also look, in this question, if your answer, as I told you in the previously, if you get 10 to the power -19, -18, minus something, that's definitely going to be wrong. What about this?
Just a second, I'm just writing down a note real quick.
The number of photons cannot be like negative power.
Determine the energy in joules per photon of radiation of frequency. Okay. Use Planck's equation to determine the energy, okay, in joules per photon. So I'm just doing hc over lambda, but I have a frequency here. So that means that I could do E equals
What is the
H.
relation?
I could do E equals H nu, right?
Yes, that's right.
So 6.63 times 10 to the negative 34 power times the wavelength given, which was, no, not wavelength, the frequency, 5.8 times 10 to the 15, and then it gives answer E, echo.
That's correct.
Okay. Okay.
What about this?
7 or 8?
You have to think a little bit in this case.
7?
Yes,
Oh, yeah.
it's easy, but
Alright, calculate the
you have
energy
to combine many concepts.
Energy in kilojoules per mole of light with a wavelength of 360 nanometers. Alright, so first thing is I'm going to convert nanometers to meters, right? Okay. Just getting a new piece of paper real quick. Alright, 360 nanometers to meters. 360 times 10 to the minus 9, or minus 9 meters. Okay. That's my wavelength. Okay. Calculate the energy. What they want, energy in kilojoules per mole. Okay. We have, if E is equal to, so H is C over lambda. Let me see. 6.63 times 10 to the minus 34 times 3 times 10 to the 8 power divided by 360 times 10 to the minus 9. Okay. So 5.5250 times 10 to the minus 19. And then I have to do something here. Okay, so right now I've only gotten to the point where I'm using E equals HC over lambda, and with that I got answer A, but I know since this is probably a trick question,
yes,
you know, that A is not the right answer, but I'm at the point where I've calculated this.
you have calculated, you have reached some point, that's right. But you have to look what you need.
Like per mole.
This is only, this answer, the first A answer is joules only.
Right, joules. Okay. So if I divided it by 10, I'm sorry, by 1,000, right? So then I get the answer in kilojoules, which would be this, but it's to the negative 22 power, right? So then it's B in kilojoules. But how do I know that I'm working in moles? Like per
One mole, 1 dozen means 12. 1 mole means how much?
Okay, Avogadro's number. So do I have to divide it by Avogadro?
No, this is the energy of 1 photon, and now you have to look the energy of 1 mole, which is multiplied by Avogadro's number. Because 1 photon energy is this one in kilojoules, the B. But they are not asking, they are asking per mole. For example, if I say, let me show you, the cost of 1 watermelon is $6, and I will ask you to buy 1 dozen watermelon. Now you will calculate the cost of 1 dozen watermelon.
Yeah, we multiply it by 12.
Yeah, so similarly, they are asking per mole, and you know the number in mole.
Is it 6.2?
02 times 10 to the power 23.
Right. Okay, and then the answer here is C.
It's correct. So look, in the first step you reach joules only. In the second is here, you reach kilojoules only, but not per mole.
Yeah.
Now, in order to get per mole, you have to multiply by Avogadro's number, just like cost of one dozen.
That
Is
was
it clear?
definitely a brain teaser. Okay.
Let me, even without that, I will show you like the work also. Look here. In the first step, for example, you got this one, am I right? 5.52 times 10 to the power minus 19 joules, am I right?
Right.
And this is joules per photon. Of course, we don't
Per
write photon,
photon.
but I'm writing here
Okay.
for one photon. Now, you are going to calculate, convert joules into kilojoules. 1 kilojoule is equal to 1000 joules, am I right? Joule cancel, you will get, go to the kilojoules. And now they are asking 1 mole. This is 1 photon only.
One mole of photons.
So 1 mole is at the bottom per mole.
Yep.
1 mole is equal to 6.02 times 10 to the power 23 photons now. Okay?
Yeah, this is
Photon cancel, and this will you get 1 per mole photon. Okay. And you will get the answer. Is it clear?
Yeah, I just took a screenshot of it, of that work. Thank you. Okay. So I'll try and do number.
It's also, I think, it is similar but not exactly it's asking same but similar thing. Do the 8th question.
All right. How many?
Not same but similar.
Yeah, how many photons of light was frequency? Okay. So frequency is nu. It equals 5.50 times 10 to the 15 hertz, or 1 over second, right? Hertz is equal to 1 over second, or seconds inverse.
Which one?
Hertz.
Yes, hertz and second inverse are same.
Okay. Required to provide 1 kilojoule of energy. All right. How many photons? That's what it's asking. Photons. Okay. I just have to take a few moments to think about this. How many photons of light within? Okay. So I'm just gonna rearrange it. So E equals hc over, or in this case, I'm gonna use E equals h into nu. Okay, and that is the energy of 1 photon. Okay, so the energy is 1 kilojoule. Okay, and h, we know h, and so nu is equal to 3.5. So let's see. If I do h into nu times 10 to the minus 34, and I multiply it by the given 5.5 times 10 to the 15. Let me see. Let me see. How many photons of frequency? Yeah, do you mind walking me through this one,
Yes. Okay.
please?
You want me? Okay, no problem. Okay, again, first of all, what you have to do is
It's just
This,
taking the
whenever
two.
they give the frequency, calculate the energy of one photon.
Yeah. Yeah,
By which formula?
I did that one. It came out.
You did that one. So energy of photon is equal to, like I'm writing this one. What is the energy of photon? You can calculate this by using E is equal to h nu.
Right.
So h is 6.63 times 10 to the power minus 34 times 5.50 times 10 to the power 15.
Right.
Okay, what you will get?
Yeah, I got 3.63 times 10 to the minus 18.
3.63 times 10 to the power minus 18.
Minus 18.
Minus 18.
Yeah.
But this is in what is the unit?
Is it in joules?
Joules. Now can you convert this into kilojoules?
Yep, so I can divide it by 1,000,
Divided by 1000.
and then I get 3.63 times 10 to the negative 21 power kilojoules. Okay.
How much you are getting? Negative 21, right?
Right.
Okay.
Yeah, I wasn't sure what to do at this step, at this part.
Okay. After this.
Right.
Okay.
Yeah, I got to this
Because now you are asking the number of photons.
point. Right, yeah.
So number of photons, what you are going to do is look the total energy, how much energy they are giving you,
We want one.
and divide it by the energy per photon. Per photon. So total energy they are giving you 1 kilojoules. And look here in this kind of
So,
case.
so this numerator here is the total energy that they
Mm.
want.
No, it's not. The denominator is this one. 3.63, sorry.
Yeah.
3.63 times 10 to the power minus 18 kilojoules per photon.
Wait, it's
Per photon
21.
means,
21 minus 21 kilojoule.
oh, minus 21, sorry. Minus, let me do it again. Minus 21. So what you are getting? This is kilojoules photon inverse per photon. So that will give you the
2.75 times 10 to the 20.
okay. So look the closest answer.
Yep, 2.74 times 10 to the 20,
That's
and that
that's
is
right.
and that is photons. Okay.
Mm. And if it is like only 1 kilojoules is here, not any other number, you can also do it if you want faster. Whatever the answer you got here, already you got the kilojoules, okay?
Hmm.
And after that you can just turn, like I will also calculate this thing in the kilojoules, and then you can easily do this thing, okay?
All right. Yes. Yeah, yeah, I definitely took note of that one. Let's see.
Okay, now this is theoretical question.
Yeah, would we be
Next.
able to stop after the second one after 10? We'll do 9
Okay.
and 10.
Okay, I'm gonna stop here.
So I'll try number 9. Let's see. The existence of discrete quantized energy levels in an atom may be inferred from, let's see, experiments on the photoelectric effect, visible spectrum, diffraction of electrons by crystals. I'm gonna have to just take a guess on it. Let me see. Is it A?
Not E. Because by using the quantized energy, we explain the photoelectric effect. And also visible spectrum is not saying like this quantized. Diffraction is nothing to do with this. Atomic line spectrum, because it says quantized. Why? Because only certain energy levels you will get value. So this one, the idea of quantized comes from here.
Okay.
Like atomic line spectra, how much energy is coming out So we always get the multiple values from here.
Okay.
Because you haven't done this, so we can ignore this one if you want.
Number 10.
Otherwise, if you want photoelectric effect, I don't know whether your teacher has done or not.
No,
If you want, you can read this.
Just kind of, yeah. I'll read it. Let's see. Photoelectric effect.
First, I will explain the photoelectric effect briefly.
Okay.
Photoelectric effect is like, suppose there is a metal sheet, like metal plate. Light strike this metal plate, and if a certain if the frequency of that striking light is greater than the threshold or threshold equal or greater than threshold frequency, then electrons comes out. It emit electrons. These electrons are called photoelectrons, and the effect is called photoelectric effect. Like when the light falls on a metal surface, and if its frequency is more than or the threshold frequency, then the electrons comes out from the surface. That is called photoelectric effect. And in this case, why threshold frequency? Because in order to take out electrons, you need energy. And light radiation energy is h into nu. If this energy is greater than h nu naught, energy required to remove the electron, electrons will come out. So now read the answer this one.
Okay.
Intensity is different. Intensity means how the light has a more intense light. Light, like suppose you are putting like a more light, very vibrant light, but it doesn't matter. Maybe it has less energy.
Would it be D?
No, it's not going to be D. In this case, A.
Okay.
Contradicted the view that, because in the beginning they think that the light energy was dependent on intensity. But now we know it do not depend on intensity. It depends on, light energy depends on frequency. Because if intensity is more, the energy is not more. If energy depends on frequency, then more intense light is going to emit the electron. It doesn't matter. Because how intense the light, if its frequency is less than threshold, no electrons comes out. So this
less,
contradicts
okay.
that view.
Okay.
Okay, so we are going to stop here, am I right?
Yes.
Okay,
Yes,
so we can
please.
stop here. And whenever you want, just let me know. You can do that.
Will do. Will do. I'm gonna have to focus on. I got to.
And what chapters are going to be in the third test? Also email me like the chapter number and what, so I can see what topics are going to be there.
Okay. Yeah, I think
Okay.
it's 6, 7,
That
8.
chapter
probably.
7,
Yeah.
6,
Or 7, 8, and 9.
what,
7, 8,
7
and
and
9.
8. 7 and 8, okay. Okay.
Yeah, he said that we're only going to go over a small portion of chapter 8, so I don't believe that we'll be testing on all of it. So I'll have to let you know what parts of that chapter. So
Okay,
I'll
just
be able
tell
to
and let me know. I will.
I'll be able to
let
let you
you
know on Thursday after when I get out of the class. Okay.
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 Yeah.
Take care.
Thank you. You too, Jafri.
Bye.
Have a
Bye.
good Sunday. Bye-bye.
Bye.